We'll start. So Shadi Aldamati is trained as a neuroscientist and an avid advocate for open science. He founded OpSci as a non-profit organization to support the establishment of public commons for science. And today he's working on tools for knowledge engineering to supercharge today's spirit of discovery and innovation. Wow, what a title. All right, thank you so much for joining us and educate us on how you've used Filecoin, and looking forward to hear more.
Yeah, absolutely. Thanks for having me. I'm super excited to be here today to share some of the work we've been doing with OpSci. My journey with OpSci started off actually very much in parallel with some of the problems and solutions that are being developed by Protocol Labs, specifically through IPFS and Filecoin. And one of these issues really has to do with how do we communicate scientific data in an effective way, and how do we work collaboratively and build collaboratively on scientific data in a public commons in a way that captures the value of science in a way that benefits the researchers and those that use that data to produce the insights and discoveries that power society today. So I want to talk a little bit today about kind of our motivation for why we went down this road and why Filecoin is really important for us to achieve these goals. And the problem that we're really addressing and hoping to solve here are broken feedback loops of value flows in research and development. And so, when we think of decentralization and we think of research, it started off as decentralized, right? I mean, science really was something that happened in the garages or the sheds or the private labs of gentlemen scientists, like, for example, in the 1660s with the advent of the Royal Society. It was just a bunch of dudes gathering around and talking about philosophical ideas and coming up with different problems that they wanted to address or to solve. And so fast forward to today, and now we have a preponderance of information that's available. And you have examples like the Brain Hack community, which are truly decentralized communities, right? They're all over the world. They run these global type hackathons every couple months. And there's an active energy or kind of a passion to build solutions that benefit the community. And what we're seeing actually is kind of a transition from of expertise and training and kind of really innovative potential transitioning away from siloed institutions and into these communities where all the raw ideas are kind of bubbling together and new solutions are being put together by interdisciplinary teams. And so, somewhere along the way between 1660 and today, something kind of went wrong, right? Where we've started having an increased consolidation of the value that science produces within these institutions. And a lot of it was necessary for us to execute national strategic priorities, whether it's the Manhattan Project or whether it's vaccine development. However, if you do look at economic growth and development, it is related to basic science research output. And this is something you can actually quantitatively measure. It's called the Solo residual. If you take an exponential curve and fit it to GDP growth over the last century, you'll find that there's some things that you can't explain away with just your common economic metrics, right? And so basic science is thought to be one of those remaining sources of variance that explain away the residual behind economic growth. However, today we have this pretty big problem where public funding goes to scientists, and this public funding is usually powered by taxpayers from individuals or businesses. And the value that's created by scientists often ends up getting siloed into knowledge curators. And knowledge curators not only use scientists as free labor to peer review, to sit on editorial boards, to actually produce the knowledge, they also charge them to publish papers, open access, for example. And then on the other side of the bill, they're also charging commercial research and development teams to access this knowledge. So you're having this appropriability issue where the value of science isn't being fed forward into a feedback cycle or to fund more science, but rather is coming into those that are curating knowledge and accessing knowledge and determining what the terms of the paywall should be. So you can see a really good example of this with kind of contrasting Elsevier, which is just one of the major publishers out there, against the entire University of California system. So if you look at all of the patents, all of the intellectual property that the UC system, this includes UC San Diego, UC Irvine, UCSF, UC LA, and so on and so forth, huge institutions that have produced many, many different life-saving drugs, therapies, patents for space exploration, so on and so forth. In 2016, they were able only to turn over 22% profit margin. So that's about $48 million for them over all of their intellectual property due to royalties or licensing and that sort of thing. However, the same journals that these scientists are publishing in, right, are turning over a 37% profit margin for almost $750 million a year later. So there's something definitely wrong here. And this brings us to the question, well, how do we grow a self-sustaining knowledge creation community that's as prosperous as it is productive? And a solution to this problem, and I think Filecoin, as well as distributed file storage and cloud service technologies, are really at the heart of it. And the approach that we're taking, which I call data Kintsugi, which I'm not sure if it's a novel term or not, but it's this term that's taking the art of something broken and putting it back together to make it beautiful again. So if we look at the scientific ecosystem today, we'll see that there's this unstructured, chaotic corpus of data that's short-lived, that sometimes falls off the map, and is distributed in a bunch of different silos that are locked away due to either regulatory concerns or compatibility issues, whether, even if you did have access to it, would you actually be able to use it? And this is really what motivated me as a neuroscientist, because I worked in a magnetic resonance imaging center, had access to massive amounts of data, and wanted to collaborate with others in other continents or other countries, and it was very, very difficult to do so. So can we take this unstructured corpus and build out a data layer for science, or an interoperable federation for a data commons for science? So we've been doing just that over the past 6 months. Ever since starting to work together with Protocol Labs and Filecoin, and getting feedback on our solutions. And this is the solution that we've come up with so far. So we've identified a Web2 corpus of neuroimaging data. It's over 260 terabytes. And this data is indexed by a metadata aggregator that's really kind of common in the field, or at least in my specific field, for aggregating this data, indexing it, and telling you where those remote sources are. And so we've begun crawling that metadata aggregator's indices and starting to push that data off into Filecoin and decentralized file storage. We're just wrapping up our piloting experiment. This was done in collaboration with Textile, using some of their bidbots and the PowerGate CLI specifically. And we've put together a pipeline that could really be easily adapted to different other extra pipelines, for example, like through Estuary. This is what we're converging on now, where we want to scale this pipeline up to start archiving the majority of this data set. So the idea is that we have this public data commons that's being archived from these Web2 corpuses that might have transient data. And what we've realized actually in the process of this is data that we've been actively indexing is actually falling off the map as we're indexing it. And it's coming to be that some of the data that we're storing actually only exists on Filecoin now. Or would only exist on Filecoin if we got to it fast enough. And so our public data commons is running on Estuary on the back end, which allows us to pin data to IPFS for data routing. So individuals can grab the data, it'll be pinned there. If they're running their own IPFS node, they can also continue to pin the data. And this really opens the door for a federation of decentralized peer-to-peer data sharing for science. Our vision is, once we've scaled this up and proven it out, that individual research labs that do have extra compute hardware or extra storage hardware would be able to run their own Estuary nodes and be able to join the network as a node. And so we have these research labs, they're sharing their data, and research labs generally want to be able to allow others to work with their data sets. And so the ability to provide views on top of that data through science web apps for unaffiliated researchers will be an absolute game changer by unlocking these silos for data. So how does this data layer really kind of look like under the hood? Well, we're kind of thinking of data sets actually as an abstractions of data tokens or synthetic assets, where we can control, or not even control, but rather provide role-based access control through identity frameworks, for example, like ENS, or identity aggregation using attestations using public-private key cryptography, whether it's using an Ethereum key or a GPG key. We're actively exploring that DeSci identity or decentralized science identity directory to act as a role-based access control for these data sets, which would allow us to kind of get around some of these other issues regarding permissions and sharing. And we're looking at Ceramic as a way of constructing schemas that are configurable and forkable for other people to use and adapt as they see. So everything we're building is open source, and it's available for other people to build on and version in the way that fits their use case. And we're looking at IPFS as our distribution, and as should be obvious to the audience here, we're looking at Filecoin and also ARWeave as archival for certain types of data sets. So once we have this data layer, we can kind of bring in this application layer to begin operating on the data and providing new views. So once this is integrated with identity, once we have these pieces working together, then we can start looking at things like permissionless journals that are automated on chain that allow anybody with a pseudonymous DeSci, decentralized science identity, to submit a paper, right? Or to be a peer reviewer. We can also think of things like compute markets where individuals can upload data sets or provide cloud services and perhaps monetize those for other individuals to come in and utilize those services for their purposes. And then other potentials are, for example, data lockers, right? So for example, as a scientist, I need to be able to archive my data, but perhaps I don't want to publish it to a compute market. And Filecoin makes that possible through some of their programs like Filecoin Plus. And the end goal really here is to build applications that really serve us in meat space in the reality layer, where we're bringing networks of labs closer together to foster new forms of collaboration and to make it possible for data sets that otherwise couldn't move or otherwise couldn't be operated on unless you had some very special privileges to finally make it out there and really kind of push forward innovation with big data and science. So coming back to the appropriability question, how are we going to solve this with a data layer? Well, I think there's a potential solution here that we're crawling towards or inching towards, and we're still discovering things along the way. But the basic schema is this, where we have open access knowledge, and we want to provide a portal for private applied research, but at the same time being able to assess appropriability of that knowledge. So when open access knowledge is used for private applied research, could we start thinking of public goods taxes or public goods fees that come back into public goods treasury that feed back into open access knowledge that further promote innovation and more private applied research that generates products and services that make our society better? We can dive into this a little bit more detail. We can start thinking of things like a regenerative data commons, right? For example, where a private researcher might want to access knowledge markets for a particular type of open access data set. Sure, it's open access, it's free to download, but if they want to run a specific type of algorithm or some high intensive job on top of it, that would be something that they would pay to access for compute. And thinking of ways that we can build this into a positive virtuous feedback cycle for open access research. Here's our roadmap, kind of, if you're curious to see where we're going with this. Right now, we're in the midst of user requirements research for neuroscientists, really trying to narrow in and hone in on what they need to make their research work more smoothly, more efficiently, and to be able to innovate more quickly. We're putting together a bench to mesh backend. So this includes that 250, 260 terabytes of open access data, getting that onto Filecoin, as long as with some onboarding materials for institutions so that they could run these nodes on their own. Eventually, we'd like to deploy our knowledge market, which we have a demonstrator on testnet right now, and see whether it's something that could actually be deployed on a federated network of institutional providers. Tons of things to work out there. And later on in the coming years, we'll be looking into demonstrator workflows for compute jobs on distributed cloud service networks that are routed through the knowledge market. And we're hoping to explore a potential token community pilot where we have our DeSci identity solution matched into kind of reputation-based metrics and allowing kind of this community governance of a Web3 science commons where public and private research and development can come together to help promote science. Yeah, so I can give you just like a quick overview of the different types of components of our ecosystem. Our Open Science Knowledge Commons is up on a testnet. More than happy to, if anyone's curious, to answer some questions on that. We published a couple data sets on there, and we're working on integrating natively Filecoin into this. This is built on Ocean Protocol. We've also put together a toolbox called DARC-SPICE, or Decentralized Autonomous Research Community Simulation Program with Integrated Circuit Elements, toolbox that allows us to perform multi-agent modeling and understand exactly what happens when we tokenize certain data sets or certain commodities, and what sort of stable dynamics emerge in the ecosystem, and what design patterns work and what design patterns don't work. And lastly, we're super excited. Also, we'll probably be releasing this soon, a preprint archival server for researchers that will archive their data permanently on Filecoin and ARV. And we're expecting these different components to be integrated together. If you'd like to learn more about what we're doing, we have more full-length blog posts on all of our tech and all of our progress on pulse.opsci.io. So please do check us out. And thank you so much, Stefan, for the time and the space to share our exciting work with everyone. Thank you.
Awesome work. Love how you put more control in the scientist's hands and create tooling around it. Any questions for Shadi? I see some more people coming in. Well, thank you, Shadi, as always. Appreciate it. Great conversation, and we'll see you on the internet. And yeah, we'll hear more from you in the future, I bet, with all the optimizations and the features that you're building. So thank you.
Right on. Thank you so much for the opportunity, Stefan. Take care.
Thank you, Shadi.